A very good day to Dr. Zaini. My name is Lizino and I'm here to talk about my topic today, which is flat belt pulley. So my problem is that the design and calculation of flat belt pulley system are such one of complicated mechanical engineering tasks in mechanic of machine. So my problem is, how do we develop a design which includes the typical steps of analysis and speed calculation of the dynamo part, which is the output speed. So my objective of conducting this project is to apply the knowledge of C language that we learned this semester and develop a small simple program that can be applied in problem solving, especially in the topic of mechanic of machines. And the last one is to simplify the calculation for calculating the non-slip and slip condition in a flat belt drive system. So my methodology to calculate the speed and at shaft. So we will involve the gear ratio, which speed of output speed divided by the input speed equal to the diameter input divided by the diameter output. So if the system involves slip condition, for example 2% of slip condition, so we need to multiply by 1 minus the slip condition, 1 minus the slip percentage. So my flow chart, you can see that from the flow chart, my system from the start, my system will only run for 3 times, only 3 times. And let me continue. There are 3 cases. So if I put my input 0 or 4, there will be error. So next will be this one will be my 3 cases. Case 1, cases 2, and case 3. Next will be my my program. Well, this one is my program coding, and if I input 0, that will be error. So I will stop my program and run again. So if I input 1 and let my D1 becomes 0.75, 0.45, D3 becomes 0.9, D4 0.15, and the last one, the speed is 150. Okay, so there are 50 loops, and it will show the speed of the engine pulley N4. And I can continue to put my to insert my input until 3 input for input 1, 2, 3, as I set it like that. Okay, for the discussion part, my first loop will be my first loop will be the setting time, the running time of the program, which I mentioned before that the program can only run for 3 times, which I can just place in 3 inputs. So user, for example me, can directly obtain my solution for the 3 inputs for the 3 cases. Case 1, no slip condition. Cases 2, slip 2% at line shaft, and the last one, the case 3, which is the slip at only dynamo part. So the next one, this diagram is where my idea comes from. So there are 3 similar loops, 4 loops, but represent the 3 different cases, which is, I mentioned before, non-slip condition, slip of 2% at each drive, which involve both line shaft and the dynamo shaft. And the last one will be the slip at line shaft only. So the values of input for my project is the same, which D1 equal to 0.75, 0.45, 0.9, 0.15, and the 150 RPM. So from the results, I can discover that as the diameter of the shaft increase, the output speed at the dynamo shaft will increase too. So my conclusion, my objective of conducting this experiment are achieved. A simple program that can be applied in the problem solving and mechanics of machines is developed, which I can use the program to solve my calculation in the speed at dynamo part. And fortunately, the program made is able to run and can be used to provide a data set of speed at dynamo shaft at 3 different conditions, which I mentioned before, which is no slip condition, 2% slip at each shaft, and 2% slip at only line shaft. So that's all for me today. Thank you.